is equal summation from K0. It's important to understand that we start in K0 to M of the A, well, combinatory number first, NK. This is symbolic way combinatory number. If the formula is n factorial divided by k factorial and a minus k factorial. After that, I want to explain how we are doing the calculator, because the majority of calculators have this function, combinatory number. So a raised to the n minus k and b to the k. It's important to understand that in between 0 and m, we have n plus 1 terms. So when you expand, I don't know, suppose n is 10. When you expand totally, we have 11 terms. Okay? Okay. To say bring example, two examples in which you are doing the expand. Another case, you find one specific element inside the formula. No? Let's see. Suppose that we have x plus 2 to the fifth power, and the equation say, well, expand. You know that we have 6 terms. When you expand, you have 6 terms. How do you know? Because it's one more of the exponent. No? Entonces, now, according to the formula, let me copy the formula one more time. Is well, it's summation, but inside the summation we have combinatory nk a to the n minus k bk, and k vary from 0, 1, 2, 3, 4, 5 to 5. Yes, n. So we have combinatory number 5, 0, because this is for k equals 0. A 5 minus 0 times b to the 0. This is my first example. So I leave it in detail, step by step. After I want to do fast, because you know the b to the 0, 1. Now the second combinatory number 5, 1. A to the 5 minus 1, b1. It's easy. Combinatory number 5, 2, a 5 minus 2, b2. And this is important because when you add in this exponent, 5 minus 2 plus 2 is always 5. Okay, the original number, right? Okay, let me continue down. Down is 5, combinatory number 5, 3, a 5 minus 3, b3, plus combinatory number 5, 4, a 5 minus 4, b4, plus the last guy is combinatory number 5, 5, a 5 minus 5, b5. So I'm using that formula 6 times. Of course, a summation. There is a reason we have 5 elements from K0 to 6 to M, okay, 6. It's a K0, K1, and so on, no? K1, and so on. K2, 3, 4, and 5. Okay, combinatory numbers. Okay, suppose I can apply the formula or no. Because this is easy, because it's only 5. You remember the Pascal triangle that look like that. 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And this Pascal, this is for n equal 0, n equal, no, this is 2, this is 1. I forgot something in the middle. I forgot 1 on the top and 1, 1. This is N0, this is N1, and so on, no? N3 is the coefficient, N4, and N5. Okay, so now, this guy, que es 1, es combinatorio number 5, 0. Is this. Just in case, let me try to compute with the formula. What formula? That formula. Suppose 5 factorial divided by 0 factorial, because k is 0, and 5 minus 0 factorial. No? So, it's important to say that 0 factorial by definition is 1. And 5 minus 0 is 5, and 5 factorial divided by itself is always 1. Now this guy is 1, this guy is 1. A, but 1 is invisible. Not necessary to write that. No. It's a to the 5th power, and b to the 0 is 1 also, because any expression or number raised to the 0 power is 1. I did the first one. The second is combinatory number 5, 1, que es 5. I want to prove, if you want, in the factorial. Okay, and is 1, F5, 5, what? This number is 5, this number is 5. A to the 4, B to the 1. And 1 is invisible. Plus 10, is this guy, a to the 3rd power. You know how the exponent for the a decreasing. But wait. Sorry, I make a mistake. In our problem, we have no a and b. We have x and 2. Wow, I am crazy. Look. Well, okay. Let me finish with the a and b and after replace. This is a to the cube, b to the 2nd. Okay, no problem. Plus, this is 10 again. Look, this number is 10 again. A to the 2nd, b to the 3rd, plus, and this is 5. This is 5. A to the 1, 5 minus 4 is 1, b to the 4, plus, and the last case, combinatory number 5 is 1 again. And this is a 0, 5 minus 5 is 0, no a, and b to the 5th. But in our specific problem, a es x and b es 2. Okay, no problema. Entonces es x to the 5th power plus 5, x to the 4th power multiplication by 2, no? Because b is 2. Es numerical value. Actually, entonces 5 times 2 is 10, no? I don't know, in the next step we are doing 10 x cubic and 2 squared is 4 times 10 is 40, okay, no problem. And 10 x squared, because a is x, look at that, and b is 2. I like so much doing this substitution at the beginning, no, but okay, I confused. And b is 2, entonces 2 times 2 cubic, and 2 cubic is 8 times 10, 80, plus 5x, and 2 to the 4th power is 16, 16 times 5 is 80, no? Yeah, plus 2 to the 5th power is 32. My final answer is x to the 5th power plus 10, x to the 4th power plus 40, x to the cubic power plus 80, x to the 2nd power plus 80 again, coincidence, x plus 32, because 2 to the 5th power is 32. This is my final answer. Everyone follow me, or it's confusing? You want to explain one specific part? Let me know. Maybe the confusing part is the combinatory number, right? Suppose, hypothetically, suppose could you compute a combinatory number 53? Let's do it by hand and calculate. And we did that using the Pascal triangle, but no, suppose another more complicated example is to the 9 power, to the 10 power, to the 12 power. Entonces es too long, the Pascal triangle, no good. Entonces 5 factorial divided by 3 factorial, multiplication by 5 minus 3, que es 2 factorial. Bueno, 2 factorial es 2, es 2 times 1. 3 factorial es 3 factorial, leave it like that. And 2 factorial is 2, because it's 2 times 1, no? And 1 is invisible. And 5 factorial is 5 times 4 times 3 factorial. 3 factorial cancel. 5 times 4 is 20, and 20 divided by 2 is 10. Boom. And this thing is exactly the thing, okay, right here. This guy is that guy. Okay. Let me show you in the calculator. Of course, I want to show you in my own calculator. The calculator I have here, I have the emulator online. Let me try to show you. Calculate. Where is the calculator? Oh, I don't see the calculator. Oh, why? Cancel. Okay. Calculator here. Okay, now, if you want to see the calculator, let me share, switching to the screen. Ah, there you go. I found. Look, do you see the calculator or not? Not yet. Not yet. Do you see it or not? Let me see the same example. The same example was, let me check in the whiteboard. It's combinatory number 53. Okay? Okay. Let's do it. Combinatory number 53. Combinatory number 53 is. Okay, do you see here? You click in this calculator. In one calculator is different. You need to check in your username manual. No? This you press second math and display a menu and navigate inside the menu. And it's a probability because this combinatory number is using a probability. And you expand this and you see in the second option combinatory number. And the third option, NCR. And you enter NCR. And the number was 5,3 because the N, K. When you press enter, bam, 10. You see, it's easy. Combinatory number. And the majority of calculators we have that. Cool. Excellent. Let's see another example. Let's see another example. In this example 2, we have 2y minus 3 to the 4th power. Entonces, the new thing que bring me this example is que es minus, no plus. Because in my formula, I want to copy one more time my formula, is a plus b to the n power a summation something of the combinatory number nk, a n minus k bk, no? And this summation go from 0 to 1. Okay? K equals. What happens if you have minus? Well, you can interpret of course que A is 2y and B is negative 3. So A is 2y and B is negative 3. Okay, no problem. Then you write N is 4, so combinatory number 4, 0. 8 is 2y raised to the 4 power, and minus 3 raised to the 0 power. This is my first term. Remember, we have five terms. This case 0. Plugging in 0 here, 0 here, 0 here. K1 is 4y 2y raised to the cubic power, because you're decreasing 4 minus 1, and negative 3 raised to the 1 power, 0 plus 1. What is the next guy? Well, the next guy is combinatory number 2y raised to the second power, decreasing, and negative 3 raised to the second power. That was k equal 1. That was k equal 2. And remember, we have 5. Okay, so it's 1, 2, 3, 4, and 5. 2 more. So now the second is combinatory number 3. This continue, no? Plus 3, 2y raised to the 1 power, because decreasing, and 1 is invisible, no? And negative 3 raised to the cubic power. Plus the last one. Okay, the last one is 4. Okay, 2y raised to the 0 power, and negative 3 to the 4 power. Guys, I need to go to the restroom now. Okay, I immediately go back. I am here. Let's continue. Okay, combinatory number 4. You can use a calculator or either way, is 1. So basically, this guy is 1, but this is not 1. This is 2 to the 4 power, gets 16. Y to the 4 power. And this is 1. Done. Plus. Combinatory 4 is 4. This guy is 4. You can see in the Pascal, or using the calculator, or using the formula. And this is 2 to the cubic power, gets 8y. And this is negative 3. And you multiply 4 times 8 gets 32, times negative 3 gets minus 96 y cubed. And this is important to understand that when it's minus inside the binomial, the sign is alternating, positive, negative, positive, negative, positive, negative. The exponent enclosed negative 3 is even number, like a 0, like a 2, like a 4. The answer is positive. See, the exponent is odd number, like a 1, like a 3, you know, entonces es negative. Entonces now the next guy is, well, 216 y squared will come from 216. Okay, combinatory number for 2 is, I'm using my own calculator that I have in my hand. Combinatory number, probability, combinatory number for 2 is 4,2, is 6. This guy is 6. And this is 4 to the second power, is 4y. square, and it's a 9 because the negative 3 second power, and do multiplication 6 times 4 times 9, and I said 216 y squared. Super perfect. Now the other is similar, is minus, but this is negative. Actually, this is the same value. Let me try. Combinatory number for 3 is 4 again. It's a coincidence because this is symmetric. This is 4 times 2 times 27 because it's 27. It's a 3 to the cubic power of 27. Actually, it's negative 27. The multiplication 4 times 2 is 8 times 27 is 227. Sorry, 27. I make a mistake here. 27. Sure, mistake again. Okay, F here 27. 2. It's a coincidence because 260. Why? Plus 81 because negative, well, this is 1. This is also 1 because the 0 is 1 always. And this is even exponent, the answer is positive. This is 3 times 3 times 3 times 3, 4 times, so because 81. That is the answer. You follow me? You follow me? Yes or no? Okay. Yes or no? A ver, answer me. Say something. It's confusing. What part is confusing? Yes, Professor. Giselle. Okay, Giselle. Now I want to complicate a little bit your life. Because I don't want to expand everything. No. I want, for example, let's give them 2 binomial x plus 2 raised to the 9th power. Okay, by the way, this contains 10 terms. But no, I don't care the 10. I want one specific, the 6 terms. The tricky part is in the 6th position, KFI. Remember, when you expand this, the first guy is K0 plus the second guy is K1. The third guy is K2 plus K3 plus K4, and this is plus K5. Let me count. 1, 2, 3, 4, 5, and 6. It's exactly the same. I need the 6th position. Therefore, KF5. It's easy, not necessarily do it this way. So you say que es 6, so you're decreasing 6 minus 1 is 5. KF5. And the reason why is that because we start count in 0, not 1. Okay, because I know the rest is plugging in the formula, no? The formula say, repeat again the formula. The formula is combinatory number nk, a minus k, bk. But in our specific example, A is x and B is 2. Unfortunately, plus. Okay. And combinatory number, I need to compute combinatory number. N is 9. This is M is 9. And our specific problem is combinatory number 9, 9, 5. Because K is 5. Look at that. And A is x raised to the 9 minus 5 is 4. And B to the 5th power. Pero B is no, B is 2. Sorry, I'm crazy. B is 2. This is 2 times 2 to the 5th power. Okay, so now I put in the calculator, I suppose. Let me try to do my best. Combinatory number 9, 5. And I will calculate one more time. And when I compute this number, I take advantage of this number. A multiplication by 2 to the 5th power gets easy as 32. 5 times 5 times 5 times 5 times 5, 5 times. Entonces, basically, an exponent here, not necessarily to write like that, 9 minus 5, no, hello. It's 4 power. Okay, there you go. To make easy, I go to the calculator. Okay, you see my calculator? Let me clear everything. Clear the house, clear the history, clear the taskbar. No. I compute. Combinatory number. Look. In the menu, probability. This is my calculator, sorry. I know in several calculators to do that. However, this is a calculator that is available for me online. I have another similar on my table, exactly like that. I have several calculators, but this is the most. Okay, you expand this menu, you select the option combinatory number, get the third option, and you copy 9,5. Because n is 9, k is 5. And the answer is 126. Okay, but you multiply by 32, and the answer is 4,032. So what is my final answer? Well, my final answer is, let me come back to the whiteboard. See? Okay. I suppose you see whiteboard, right? And the answer for this was 126. Multiplication by 32, the answer was 4,032. X to the 4 power. Boom. Finals. You see that? Let me try now to do another kind of problem. In the review packet, we go over again to this. I promise. Okay? Okay. Another kind is not exactly position. For example, suppose this. Suppose we have binomial. Okay, the binomial is x minus 3 raised to the 10 power. Wow. N is 10. But not specification position. No. Specification, the terms que contain the term is singular, only one que contain x to the cube power. I want to expand it, and you select one guy specific que contain x to the cube power. Pero no necessarily expand everything. You can, pero no, because we have 11 terms. No? I use my formula. This is my formula. Combinatory number AK, A, n minus k, bk. I know que es summation from 0 to n. And the index variable is k. However, I want to discover where's the guy. Okay, entonces A es x, cool, and B is negative 3. And A is x. Okay, no problem. Combinatory number 10, n is 10. Okay, I have no idea. Because the idea I have is this exponent is x. A is x. Is cubic. So the clue is QB is this exponent. So this exponent is equal to this exponent. So now I take advantage. Okay, I know that this is n is 10. 10 minus k is equal to n is 10 in our specific, but I need that these answers que they only have k. They have x que es a, exponent 3. And b is negative 3 to the k power, but I have no idea who is k. But I can find now. It's 10 minus 3 is equal to k, so for k, this elementary kindergarten equation, and k is 7. Okay, so basically I come back to the expression is combinatory number 10, 7, x to the cubic power, and negative 3 raised to the 7 power. You put in the calculator, this combinatory number is 10 factorial, something, say, the answer is 120. This is 120, you can verify. And this is big number because it's multiplied by negative 3 7 times. And of course, negative is solved because the exponent is a odd number. So it's minus 2,187. Finally, multiplication, both 120 times this, the answer is negative, of course, negative, 26 to, so 262,440 x cubed, and it's the answer. The basic, we have 4 kinds of problems. One problem in which you expand everything. This is easy, but it's long. Another problem que hay specification, the position. In the position 5 and the position 6, and you determine who is k, and you keep going. The another que I specify some features. I don't know, suppose another problem is x plus y to the 40 power, but I need the term to contain x to the 15. Okay, and 40, 41. When you expand it, it's too long. Wow. So no. We focus on the equation, You discover who is A, who is B. A is X, B es Y, pero the guy que I need es 15. Entonces you declare que this is 15, and you solve for K, and you determine the position, and the rest is super easy. Super easy. No problema, guys. Okay, entonces we start review. I suppose that you have the review in your hand, your hand, in the computer, in the laptop or computer. And we start at the beginning of this chapter. Slow down. This is a super important moment. You need to understand everything perfectly. Okay, any question, any minimum question, let me know. Okay, so now in the question 1, we have a conic section. 25x squared plus y squared minus 350x, wow, plus 1200 equal to 0. Now this is a crucial moment. Identification. I need to know my memory. When you have x squared and y squared, and plus in between them is ellipse. So you have x squared and y without square, maybe equal plus a parabola. Or y squared x is also parabola. And when you have x squared minus y squared, or y squared minus x squared hyperbola. It's obvious in our example we have x squared and y squared. Different coefficients. It doesn't matter. You have here a and b. Different coefficients. SLX. It's obvious SLX. Do you see that? Yes or no? Identification. First, identification. Cool. Oh, okay. Because I need to do my best in order to express it, my equation in standard. Standard, remember, we have two possibilities, no? x squared over a squared plus y squared over b squared. Sorry, I forgot something important. I forgot that we have translation. X minus h squared, y minus k squared equal 1. Yeah, I don't know. Well, see, I know. I don't know. How do you know that we have translation? Because we have linear. When you have linear term like that, we have translation. Pero only translation in x and no translation in y. Okay. Okay. Much better. Now you are doing the completely the square. You grouping the x and the x separately here. 25. Yeah, I try to do my best to find the greater common factor. The greater common factor between 25 and 350 is 25. Because 350 is 25 times 14. So you divide. You put in the calculator 350 divided by 25. Yeah, I discovered that 25 times 14. I did in your moment. Let me verification now in my own calculator. So we have 25 times 14. Boom, 350. Okay, so you factor out 25. You have x squared minus 14 plus box. Inside the box is the magic number that allow me to complete the square. Plus y squared, no complete the square of y squared, because we have no y linear. Because in the right hand side we have minus 1200 plus a box. This is the organization. Do you follow me so far in this organization? Now remember, you take that number 14 divided by 2 and square. Always the same formula. It's b over 2. The formula is b over 2 squared. And give me magic number. Magic number of what? I'll complete the square. 14 divided by 2 is 7. And 7 squared is 49. And it's 49. Put it here. 49. Now when you are doing this action, for sure, this new trinomial you form is completely square. Oh, be careful, because I forgot this box. And this box not necessarily is equal 49, because 49 is inside one parenthesis, the multiplication by 25. So actually, I copy 25 times 49. Wow. Let me erase this. This is 1225. Okay, where come from this? This is multiplication 25 times 49. Okay? Because you introduce artificially in our equation 49 because I want to complete the square. So you introduce this number artificially in order to keep the equilibrium of the equation, because this is sequence sign. Obviously, you introduce no 49, you know, the multiplication 49 times 25. The 25, this is a perfect square trinomial. Perfect square trinomial, the factorization is only one. Only one binomial case, x minus 7. Where come from this? X is square root x squared and 7 is square root 40. Okay, the Arimatic 14 is, you know, producing when you apply 40 here. Plus y squared. In the right hand side we have 25 because it's 1225 and 1200. Subtraction is 25. Almost I finish. Now finally, remember in the standard equation we need right hand side 1, and you divide everything by 25. 25, 25, 25. Therefore we have x minus 7 squared over 1, because 25 divided by 7 is 1. If you want, you put a 1 or no, either way. plus person I don't like. And y squared plus y squared over 25 equal 1. Wow, nice. This is my nice equation. Guys, this is unbelievable. Because this equation is equivalent 100% to the ugly original. It's the same equation algebraically. Of course, when the one specific manipulation, no? Yeah, we did before. Now, for me, it's easy because my habit is identification, the most important parameter of the elixir. Look at this. I know very well that the center of this elixir is located at the point 7, 0 because H is 7 and K is 0. So basically, I try to do roughly a sketch by hand after we are doing this, of course, officially. Nice, beautiful. 1, 2, 3, 4, 5, 6, 7. This is my center, 7, 7. Okay. Now, who is A, who is B? A squared, B squared. Remember the idea that we are using always. Who is A? Who is A squared? Okay, I don't know. Who is B squared? Okay, I don't know. Help me, please. In this equation. Compare this equation and this equation. Compare. Well, not exactly the same. Remember, A is always the major axis. And the major, we have two coefficients, 1 and 25. No? A is 1. A is 1. Yes, you're right. A is 1. And B is, so A squared 1 is the minor. Therefore, A is 1. Cool. I understand very well this. And what about B? B squared. Who is B squared? And who is B alone? Fi. 25 and square root 25. Fi. B Fi. Cool. Therefore, no. Something is wrong. No. Something is wrong. I don't know. I make a mistake. It's unforgivable for me. Remember, definition A is the bigger number. No. Who is the bigger? The bigger is 25. Therefore, A5. Okay. Definition A is major axis, no minor. I don't know. I confuse. And B squared is 1, therefore B. Yes or no? So no. I compare. Well, no, but this is one possibility of the equation. Another possibility is x minus h squared over b squared plus y minus k squared over a squared equal 1. How you make a decision is using this or that one. Well, it's easy. You see the big number get 25, and this is a squared. Done. And A5 and B1. This is my question. My next question is, what kind of elixir we have? We have elixir like that or elixir like that. This is horizontal and this is vertical. What do you think? Horizontal or vertical? What do you think? You don't remember? Remember, one more time. A is the major. Oh, no, exactly. Semi-major. Semi-major is the distance from the center to this, pero A is associated with the Y. Therefore, this is this. Very good. Yes, you are right. Now, this distance is A, que phi in our example, phi in both directions. And this distance 1 because of B, because it's the major axis, minor axis. Not like that, because the big number in our equation is associated with the Y. No of this. No horizontal. Very good. And by the way, I can plot directly the vertex. The vertex from the center, distance phi, up and down. At that point, I suppose using my imagination, is 7,5, and this point is 7, negative 5, because it's down. And the minor axis 1, so the minor axis is 1 here and 1 here. At this point, okay, the vertex, let me slow down, is 7,5 and 7, negative 5. Cool. The endpoint of minor axis is distance big 1 in our problem is right left in this case because it's vertical. And this point is the point A, 0 is this point, look. And 6, 0. And this is approximately, no? My elixir look like that. Well, so we're doing the mess. Yeah, not good. And that's what you see now here. One more information we need. Well, we need the Fossey. The Fossey is C, and the formula for the Fossey is C is equal to square root A squared minus B squared. In our example is 25 minus 1, 24. So 24 is no perfect square. I put a decimal approximation at 4.89. Sorry. Therefore, the Fossey as always happen lie on the major axis in this line. Where this distance is very, very, very close. Let me use another color, blue, to the phi. What distance? Well, no, the distance is 7, 4.89, and this is 7, negative 4.89. Something like that. Any question? One example of this you see in the test. Okay. Let me share with you the Desmos graphic to see more clear. Okay, over there. Share the screen. You see Desmos? Now I'll accept. Get the question one. Look at that. I make it zoom to see clear. Center is located at the point 7,0. Vertex is located at the point 7,5 and 7, negative 5. Endpoint of the minor axis 8,0, 6,0. And Fossey very, very, very close to the vertex at the point 7, 4.899 and 7, negative 4 0.899. Clear? Clear? Clear. Okay, let's move on to the second question. Whiteboard again. Let me erase whiteboard. Question 2. Question 2, I suppose, is easy because we don't need to complete the square. No, no. Is y minus 3 square equal 4 parentheses x plus 4. Well, I see que y es square, but x no. Entonces es obvio que es parábola, ¿no? But remember, we have two kinds of parabola. We have this kind of parabola, can open up or down. Of course, one branch, not two. So one scenario is this, another scenario is this, another scenario is this, another scenario is this. So up, down, right, left. And this is the category of this is vertical parabola, and this is horizontal. Entonces now depende de the equation. ¿No? The equation is the x square and y is linear, es vertical. Si y es square and x is linear, es horizontal. Entonces es obvio que es horizontal. Yes or no? Compare. This is the classical idea that you need to keep in your mind. Parabola, one square, another no. But if y is square and x no, es linear, es horizontal. And what direction open? This depending on p. Remember, my equation look like that. Y minus k squared is equal to 4p x minus h. So you compare this equation and this equation, it's obvious que k is 3. Look, the same sign. H no is -4. Opposite sign, look. And p is 1. P equals 4p equals 4. It's obvious que p is 1. Si p is positive, then p positive, our parabola open to the right. It's a horizontal parabola. Horizontal parabola opens to the right. And what about the vertex? Remember, parabola have no center. The reason is because the parabola is no closed curve. No center. Entonces, actually it's not symmetric. En la hyperbola es no closer, pero es symmetric. Entonces, there is a reason that we have a fantastic center point. Okay, however, no, we have vertex. It's a turning point. So at that point in which hypothetically, I suppose that our parabola open is the point -4, 3. H, H, K. And open in that direction. Okay, this is my axis, but this no. Let me try to do one decent sketch of this. After we're doing this one, try to do better. Okay, therefore the vertex located at -4, 1, 2, 3, 4, and positive 3. 1, 2, 3. This is our vertex. I know. Okay, open like that. This is sketch, no good. Okay, pero P is 1. That is important parameter. P is 1. And the focus is located P distant from the vertex, inside the bound. So in my mind, the focus is here. And this point is the point -3, no? Comma 3. Yeah. This is our focus. Only one, no plural. One more important thing I need. Well, in order to determine how wider or how narrow is our parabola, you determine the focal diameter. Focal diameter is the segment. Okay, from the focus, you're moving over and down. In that case, how many units? I'm gonna see PS1 for PS4. Look. And this is divided by 2 is 2 over and 2 down, because the focal diameter is 4. Pero es symmetric with respect the axis of symmetry, ¿no? Entonces, 2 here. Actually, let me using another color. This is 3, 4, 5. This point is the point -3, 5. And this I go down to unit 1, 2. This point is the point -3, 1. Because 3 plus 2 is 5 and 3 minus 2. So now I have some idea how look like our parabola. How our parabola look like that. Of course, move curve like that. More decent graph. I'm finished now. I need the axial symmetry. It's this line passing through the vertex. In this case, horizontal line. And the equation of any horizontal line is y equals something. Y equal what? Y equal 3. Que is the K value. And directrix, in this case, vertical line. Let me use another color. Passing through the same distance for the focus is 1 here. But this is vertical line. And any vertical line, the equation is x equals something. And this something is obvious. This is -4. And 1 to the left is -5. Boom. Final answer. This is the directrix. Equation, line, sketch. This is the axial symmetry. This line, and that's it. No more information. We need. Let's see the sketch and Desmos. All in the story. As always, you are doing your graph in Desmos. You make a copy of the Desmos graph and you attach to the copy of the answer in your written test. Okay, so you know. It's doing. I go to Desmos. Okay, you see Desmos, right? This is our famous elixir, but now parabola. Boom. Look at that. Wow. Okay, that parabola has. Okay, cool. This is the vertex, -4,3. This is focus, -3, +3. Endpoint focal diameter. 2 up, 2 down, a total of 4 units. Negative 3,5 and negative 3,1. And the dotted line represents axial symmetry, que es obvio que es the line horizontal y equal 3. And this is the vertical line x equal negative 5. Boom. Final end the story. Everyone understand very, very, very well or no? Any doubt? Any question? What part's confusing, Professor? Clear. Okay, enough. Thank you. Okay. So no problem. 1, 2. You have in the question 1, 100 points, and the question 2, 100 points. Let's move on to the question 3. The question 3 is also conic sections. Also conic sections. Whiteboard. Okay, erase the whiteboard. Okay, this looks like a little bit more complicated. This is 3. Question. X squared minus 4y squared plus 4x plus 32y 32y minus 64 equal to 0. Completely disorganized equation, but I immediately identify the important part is x squared minus something y squared. Hyperbola. Hyperbola. What kind of hyperbola? We have 2 kinds of hyperbola, horizontal or vertical. Now remember, the idea behind this is that we have 2 kinds of hyperbola. Hyperbola like that and hyperbola like that. And this red one is horizontal and this is vertical. Why? Because the transversal axis is coincident or parallel to the x-axis. And this kind of hyperbola, the positive part is x and the negative part is y, like that. Do you see? To complete the idea, well, this hyperbola is vertical because the equation looks like a y squared minus x squared. Okay, so now my famous transversal axis is this. Parallel or coincident with the y. Pero no, in this case, no vertical. We focus on the horizontal because I see clear like water. Okay, x is positive and y is negative. Okay. Now the algebra. It's always the same procedure, same routine. I try to do something in order to grouping the x part. Why not grouping the y part? And 64, I move to the right hand side. I manipulate in order to complete the square. Let's do it. You copy x squared plus 4x plus box. In this case, not necessarily common factor because the coefficient here is 1. Nice. I appreciate solutions. However, in this, in the y, no. In the y, you factor out 4. Actually, negative 4. Because look like that, no? Negative something. Entonces I put y squared positive plus 32 divided by 4 is 8. Y plus 2. That was the idea in order to condensing everything in the x and the y. And what about 64, Professor? I move to the right hand side and 2 boxes. This is the organization of the Arimatic sequence. But I need help now. In your opinion, what is the magic number here in this box? Question mark. And after, what is the magic number here in this box? Question mark. Help me. Any help? I'm lost. What do you think? In the X part, what is the magic number? This is classical. This is called algebra. I suppose you need to know. I explained at the beginning. What is the formula? What is the formula? Divided by 2 and square. Who divided by 2? Is F4. F4, I agree with you. I agree with you. F4. This number F4. Where come from this 4? 4 divided by 2 is 2, and 2 squared is 4. Cool. What about the green part, the white part? What is the magic number in that case? Let me erase the question mark in green color. Help me with the second magic. A 16. A 16. Where come from 16? Is 8 divided by 2 is 4, a square is 16. Cool. So you introduce artificially in my equation two numbers, therefore at the other side you're subtracting or something, I don't know. You're subtracting, no, you put the same number. See, 4, 4, this 4 is cancelled out with this 4. But this is not 16, it's 16 times 4 is 64 and negative. Do you see what is the reason it's negative? Okay, cool. I like so much because this 64 positive and this 64 is negative, and stay at least in the right hand side 4. New factorization, this trinomial, that obviously is x plus 2 squared minus 4 y plus, because this sign is plus, 4 squared equal 4. Wow, I copied wrong. Equal 4. I make a mistake. I make a mistake. Yes, I make a mistake. The mistake I made was, look. This sign is positive. When you factor out negative, this sign is negative. It's obvious, right? You double checking, multiplication negative 4 and negative 8 is positive 32. When you factor out negative 4, it's negative 8. So this sign is negative. Let me double check it again. X plus 2, y minus 4. Cool. Now it's ready in standard. No, I need to divide it by 4. The right hand side must be 1. Okay, so now my definitely standard equation is x plus 2 square over 4 minus y minus 4 square over 1, because 4 divided by 4 is 1, equal 1. Boom. This is my nice standard. Can you help me to understand much better our hyperbola? Oh, guys, this is magic. You have a weird equation that nobody understands. Nobody understands. However, using just algebra, we convert to another that everyone understands. For example, in order to find the center of this hyperbola, the center is located at the point negative 2,4. Where I come from? This is H and this is K. Look, this is H. Let me compare with the general standard. General standard say x minus h squared over a squared. Remember, in the hyperbola, a is not the bigger. No, a is the positive. Minus y minus k squared over b squared equal 1. Cool. Entonces es obvio, in my mind at least, que a squared es 4, therefore a is 2. And b squared is 1, therefore b alone is 1. And c, bueno, the formula c and the hyperbola is different to the elixir. It's the same letter c, but it's different c. C is the square root a squared plus b squared. Entonces es square root 4 plus 1. Okay, fine. Square root 5, and the square root 5 is irrational number, but the decimal approximation to have a rough idea is 2.22. Okay. So now we have too much conclusion, center. Well, we need to find vertex. We need to find foci. Endpoint of, in this case, is asymptote. Oh, I forgot the asymptote. The equation for the asymptote is y minus k is equal plus or minus b over a x minus h. In the case that we have horizontal, no? Because we have horizontal, yeah. Entonces, en our specific example, k is 4. Y minus 4 is equal to b over a que es 1/2. Plus or minus 1/2. Paréntesis, x minus h, que h is negative 2, and double minus become positive. This is the equation of the asymptote and the hyperbola. Hyperbola always is a little bit complicated to do it by hand, but I propose directly go to the decimal, no? Okay. Okay, let me share the screen to decimals. Okay. No, I'm crazy. Decimals. Okay, let me do it again. Decimals. No way. Do you see decimals? No parabola anymore. No parabola anymore. This is the hyperbola. Boom. And this hyperbola is the green color. Have the center at the point negative 2, 4. The vertex is located a distance right and left, pero a is 2. Entonces the point is negative 4, 4. This is one vertex. Look, this guy. Another vertex is 0,4. There's a 4 unit here. The 4 unit working to the left. Entonces minus 2 is negative 4, and minus 2 plus 2 is 0. This is the vertex. Anyone, you put B here, and B here, and you connect in the asymptote. And finally, the foci, distance C, que distance C is 2.23. We move 2.23 to the right, and 2.23 to the left. Yes, it's approximately the same idea, but there's no negative 4, so negative 4 plus something, que es 4.236. More clear? The hyperbola? So you want, for example, you omit the asymptote to see more clear. Okay. And this is an important point. No, okay. The asymptote is, it's important because the asymptote, remember, it's a hyperbola, has 2 branches, and the curve approaches but never touch. Look like a slant asymptote. Look. You make a zoom, never touch. Never. Any question, guys? So in the test, you can see the test I am sending Monday this test number 4, and an email of the lecture for the Monday, and even best due July 28. Any question? No? Okay, cool. Try again. One more. Question number 4. It's another different topic. Question number 4 is summation. Okay, find the sum of this sequence. So, is summation notation from k equal 1 to 16 of the something weird is parenthesis to k plus 1. And you apply the property of the summation notation in which the linear operator. What mean to be linear operator? Well, you separate, when you have plus or minus, you separate into summation. A ver. Emily, what happened, Emily? I don't read. Accident. Where accident? What happened with the accident? Emily, what is the accident? Or computer have? Oh, okay. But my computer or your computer, Emily? Okay. So now the thing I tried to explain it was, can you separate into pieces? The first piece is k from k equal 1 to 16, and you factor out these two, because a constant outside of it. And you have summation from k equal 1 to 16 offset. Okay. And you have formulas. For this guy, I want to recall that formula. This formula is easy, that part, because it's just multiplication. 16 times 7 is 112. That part. This is a little bit more complicated. It's two factors, and the formula is, let me copy the formula. The formula is n plus 1 divided by 2. But in our specific example, n is 16. So it's 16 times 17 divided by 2. And this 2 is cancelled, of course. Now multiplication, 16, 17 is 272 plus 112. The answer is 384. Boom. Final answer. Super easy. Any question? Do you follow me? How many questions in total we have? Okay, so it's too long. No, but we destroy Mondays for sure. Let's do it today. Let me see, 1, 2, 3 more, and that's it. Okay. Everyone understand very well number 4 question? No graphic, only paper. Okay, number 5. Number 5 is a little bit more complicated because we have summation, notation again, but start in 3. And remember, we have no formula for 3. We have only formula for 1. It's k squared minus 10. One more time, we separate. Linear property. Okay? Entonces be careful, because it's a little bit complicated. In this case, when the summation is not completed, the mnemonic device to memorize this. When there's 1, it's easy. You multiply this and this. And when there's no 1, no. You subtract 16 minus 3. Get the difference between this plus 1. Why plus 1? Because in between 3 and 16, including both endpoints, 3 and 16, we have 14 numbers. Okay, no 13, 14. And 13, or 14, sorry, multiplication by 10 is 140. And the answer of this part is 140. Cool? This is the detail. If this, if the summation is starting 1, no, it's super easy. You multiplication this and this, boom. When there's no 1, so you're subtracting the upper limited minus lower limited and addition. Okay. Now let's move on to this, because look like we are. Because I know formulas, I know very well that formula is, you know, summation from K1 to M of K squared. The formula is, guys, this formula is important. I promise that you use it in calculus. Is M times M plus 1 multiplication to M plus 1 divided by 6. Okay, so now I know. Okay, the summation, okay. The summation is, suppose that I need the summation. This is 1, this is 16, or this is 3. I need the summation from 3 to 16. Guess this. But I have no formula, because my formula always starts in 1. But I can compute this and subtracting this. Plus, minus, equal, x. Okay, so you want to find summation from k equal 3 to 16 of k squared is equal summation from k equal 1 to 16 k squared gets whole thing, but I make a mistake here again. It's not 3, it's 2. It's the previous of this, right? Plus no minus, you're subtracting another summation that starting 1 and ending in 2 k squared. And you get, in this case, suppose que worst scenario, que you don't remember this idea, no problem, because it's 16. It's relatively easy to compute that. You can do by hand, expand the 14 element and you add it. It's possible. But no, I want to use the formula. No? So the formula is, using the formula, that formula here and here. So basically 16 times 17 times 33. Why 33? Who is 33? 2 times 16 is 32 plus 1, 33. Divided by 6. Minus something. Minus 2 times 3. Because it's 2, n is 2. N plus 1 is 3. And 2n plus 1 is 5, no? It's 5 because it's 2 times 2 is 4 plus 1 is 5 divided by 6. It's easy. Look, 2 times 3 is 6. And this 6 and this 6 is gone. It's cancelled. And we compute that bar. Calculator maybe. Is 1,496. Multiplication this divided by 6 minus 5 is 1,491. Okay, and is the final answer? No, this is the answer for that part. This is the answer for that part. For the first summation, it was complicated. But the total answer is this and this together. No, subtraction, sorry, subtraction. Is 1,491 minus 140. And the answer is 1,350. Boom, final answer. Any question? Do you understand very well or you are totally lost in that part? Come on, question. Any question? Understood. Okay. Understood. Everyone understood? Let me go again to the restroom. The problem is, guys, the day is too hot. I need to get to drink Gatorade. And the Gatorade is amazing to make a pick. But it's okay. Let me try again. I'll be right back. Let's do 2 questions more, and that's it for today. Okay. Entonces, no problema, guys. Everyone understand very well? Okay. Question 6. Question 6 is about. Let me see. Let me record. Oh, this is the arithmetic sequence. So, one information is given in the arithmetic sequence. A1 is the first guy, is -4, semicolon, and common difference is 9. Okay, entonces now si es positive the common difference, I suppose que our arithmetic sequence is going up, it's ascending, increasing the number, right? It's okay. It's not important the same thing. The important is that I need to find a sub n expression is implicit and specific a sub 6. So first of all, I want to find a sub m for any position. And the formula is clear. The formula is a sub m is equal to a sub 1 plus parenthesis n minus 1 d. It's the formula for any arithmetic sequence. In our specific example, this is -4 plus a minus 1 multiplication by 9. Okay, leave it like that you can, but no. Much better manipulate a little bit. Distribute the property 9m minus 9 minus 4. I suppose it's 9m minus 13. Okay, let me check in my word and a piece of paper. Yes, it's the answer. It's the answer. This is the a sub m explicit formula que generate our full geometric sequence under this condition. If I want to find the guy in the position 6, plug it in, replace, and for 6 is 9 times 6 minus 13. Okay, this is 54 minus 13, 41. Boom. One answer, 2 answers. Any question? That part is easy. That part of the sequence, in my opinion, I respect of it. Let's do number 7 and end the story. We finish for today. Sorry. 7 is A1 is 0. Okay, the first element, the first terms in this sequence is 0. Okay, but this 1/10 fraction, but it's positive. That's being increasing. Therefore, one more time we apply the formula. A sub n is equal to A1 plus n minus 1 d. But in our example, A1 is 0, nothing here. A minus 1 multiplication by 1/10. If you want to write more understandable, is n minus 1 divided by 10. Okay, so now the explicit formula is n minus 1 divided by 10. If you want to find in the position 27, the problem says plugging in n27 is 27 minus 1 divided by 10 is 26 divided by 10, and you always never live like that. When you get the fraction and the final answer, you must reduce the lower term. Or you express the n decimal, que es 2.6. But no, I like n fraction divided by 2, 13, divided by 2, 5, and that's it. We cannot reduce anymore. This is the 13 over 5. Oh, 2.6. Cool. We are the best in Miami College? Yes or no? Tell me, guys. Yes, we have the best. Okay. So I wish you good afternoon. I only want, unfortunately, to say bye because I have another class after this. Okay. We continue Monday with the finish the review. Monday, remember, I will send the test. I will send both. I will send the test number 4, and I will send the final test for the student you need to take. Okay, the student you need to take. Okay, so now Monday you receive both, and remember, do Friday, the same week. No problem, my pleasure. Always do my best for the students. Bye bye, guys. Thank you so much.